When your app feels slow, where do you start? Is it the front-end code? A laggy image? A CDN region halfway across the world? That's where Real User Monitoring, or RUM, becomes your best ally. It captures exactly what real users experience, every load, every interaction, so you can find what's slowing things down. In this part 1, we're hunting down real-world slowness with Datadog RUM, starting high-level with core web vitals, then narrowing to the pages and users that feel it most. By the end of this first episode, you'll know exactly where to focus your performance work before touching a single line of code. Ready? Let's get your app feeling fast for real users. Before getting started, do not hesitate to subscribe to our blog or join our community for additional tips I do not share on YouTube. We'll start broad, a global performance overview of your application. Before we zoom into the details, it's important to understand where your biggest performance gains could come from. This high-level perspective helps you decide where to focus your time and engineering effort. To get there, go to Digital Experience, RUM Applications, and open the Performance Summary. At the top, you'll see a high-level snapshot of your application's health. From here, select the app you want to analyze, in my case, the demo blog, and choose your time range. RUM events are retained by default for 30 days, giving you plenty of data to spot performance trends over time. Here we can immediately see a breakdown of page performance. Good pages that load smoothly, needs improvement, and poor performers that slow users down. This categorization helps you instantly spot which views deserve your attention. From here, we'll dig into what's driving those slow scores and how to target them effectively. Right below, you'll find Core Web Vitals, the key metrics recommended by Google to evaluate real user performance. For web apps, these include largest contentful paint, LCP, cumulative layout shift, CLS, and interaction to next paint, INP. If you're monitoring a mobile app, you'll see equivalent metrics tailored to the mobile experience. Each of these metrics tells a different story. LCP shows how fast your main content becomes visible. CLS reveals layout instability, the visual jumps that frustrate users. INP measures responsiveness to user input. These values are based on real user sessions, giving you a true picture of how your app performs in production. From here, you can quickly identify where improvements will have the biggest real-world impact. Scrolling down, we get a broader context: performance errors, recent deployments, and resource-level bottlenecks. This section helps you correlate slowdowns with releases or code changes and pinpoint which assets or endpoints might be behind them. That's what we'll focus on next. Before drilling into individual pages, it's useful to step back and ask, is the issue global or isolated to a few critical pages? RUM makes that distinction easy. You can visualize performance by page view, user location, or device type, and immediately see whether slowness is widespread or localized. Now that we've seen the global picture, let's zoom in. The next step is to analyze performance by page view. Which pages have the weakest core web vitals, and which ones are performing well? For mobile, you'll see similar insights through mobile vitals like frozen frames or slow renders. This breakdown helps you prioritize the pages that impact your users the most. At the top of the summary page, select the Optimization tab. Here you'll see those same core web vitals, but this time broken down by individual views or pages. The table automatically sorts by most visited pages, helping you focus on what matters most for overall user experience. If your application has a lot of pages, don't worry. Filters make it easy to focus. You can slice performance by environment, production versus staging, team ownership, or release version. This helps you quickly detect differences between environments or find regressions tied to recent deployments. As mentioned, you can filter by service or application version. This is especially useful after a new release. It lets you compare performance before and after deployment, or even during A/B or canary testing. With one click, you can confirm whether a new feature improved performance or introduced regressions that need attention. Next, let's look at geographical performance. Since your users are spread across the world, your app's speed often depends on network latency and CDN coverage. Here we can compare page load times between regions like Japan, Australia, or Brazil, and see where optimization might help, for example, by using edge caching or local content delivery. You can also break this data down by browser or device type. Maybe Chrome users have great performance, but Safari or Firefox users are lagging. Or perhaps mobile browsers are more affected than desktop. This high-level comparison helps you prioritize where to dig deeper next. At this point, we've identified which pages are slow and which users are impacted. The next question is, why? Often the root cause lies in specific resources: images, scripts, fonts, or API calls. Let's move from the page view into the resource layer to uncover what's actually slowing your app down. Exactly. Every page depends on dozens of underlying resources. It could be a heavy JavaScript bundle, an unoptimized image, or a slow API call. By investigating resource performance, we can see precisely which files or endpoints are dragging your metrics down and start fixing them. Once you've identified a page with poor core web vitals, the next step is to find out which resources cause it. Scroll down on the summary page. You'll find a list of slowest resources, sorted by impact. This helps you isolate whether it's large images, third-party scripts, or backend fetch calls that are affecting performance. From the resources dashboard, you get a clear, aggregated view of all assets across your monitored apps. You can choose to analyze everything at once for a global overview, or narrow the focus to a specific application if you already know where issues are. For this demo, I'll start with all applications selected to get more data points, then drill down as needed. If you'd rather target one particular view, you can filter by view name to see only the resources linked to that page. Here I've applied a last 30 days filter, which provides enough sample data to understand trends. This gives me a clean overview of all resources associated with my slowest pages, ready to investigate. Looking at the breakdown by resource type, we can see how our app loads JavaScript files, images, API fetches, and HTML documents. The dashboard highlights both the heaviest and the slowest resources, and sometimes those overlap, but not always. For example, a large image might load quickly through a CDN, while a small script could be slow due to network latency. This view helps you spot those patterns instantly. Here's the full picture. We can analyze both the slowest resources and the most requested ones. Sometimes, a slow resource doesn't matter if it's rarely used, but a frequently requested file that's even moderately slow can have a massive impact on user experience. This dashboard gives you a 360 degrees perspective on which resources truly matter for optimization. For example, this document file is requested hundreds of times and consistently loads slowly. That's a clear optimization candidate. Just below, we can also examine fetch resources, all API calls, and network requests made by the app. This helps you connect front-end bottlenecks with potential back-end latency or failed requests. Now let's check the failed requests. Here, we can spot HTTP 4XX and 5XX errors, which often point to backend or configuration issues. For example, this 499 error means our app get a cancellation error from some backend, a classic case where front-end requests are fine, but the backend is responding too slowly or rejecting them. Having this data side by side with performance metrics makes troubleshooting much faster. If you want to dig deeper, open the Resource Timing tab. This shows a full breakdown of how long each network step takes, from DNS lookup and TCP connection to time to first byte and download time. It's like peeling back the layers of latency. You can see if your issue is network related, server-side, or tied to the content itself. Sometimes it's not about making files smaller. It's about improving how and where they're served. Third-party resources often hide performance surprises. Here, Datadog lists every external domain your app depends on: ad scripts, analytics, fonts, image CDNs, and more. For example, my blog uses Unsplash for high-res images, and I can see exactly how those requests behave. This makes it easy to tell whether external dependencies are slowing your users down. To investigate a specific resource, just click on it. Here, I'm filtering by resource provider name = Google, so I'm only looking at files served from Google domains. This helps isolate potential CDN issues or third-party library slowdowns, like fonts or analytics scripts loaded from Google servers. Every graph you see now is scoped to that specific provider. If I remove that filter, I can also zoom in on one specific resource path instead. Say earlier I noticed a slow loading image or JavaScript file. I can paste its path here and instantly see all performance metrics tied to it. That includes response times, size, and how often it's requested, everything I need to decide whether it's worth optimizing. From here, I can analyze this resource over time, or split by attributes like country, browser, or device. Looking again at connection time or download time, I can pinpoint where the bottleneck is. Maybe the issue is regional latency, or a particular browser's handling. These insights guide concrete fixes that directly improve the user's experience. Ultimately, every data point here represents real user impact. Behind every slow request is a user waiting for a page to load, And that's exactly what RUM helps us make visible. That's a wrap for part 1. We started global, drilled into core web vitals, and mapped impact across pages, geos, devices, and user segments. You now have a prioritized short list of views and resources that move the needle. In part 2, we'll go deeper, exploring the raw data and adding new segments that actually make sense for your business. In addition, we will also cover the long tasks. Hit play on part 2 when you're ready to turn insights into fixes. Until then, subscribe to our blog or join our community. And as always, happy monitoring.